Okay, good morning, everybody. Good afternoon, good evening, depending on when you're watching this Cisco networking class from. Okay, in the previous slide explanation for the Cisco IT Essentials training course, we looked at Module 1, Module 2, Module 3, Module 4. Well, we've looked at the components of your PC. We've also looked at the motherboard, the RAM, the processor. We looked at troubleshooting. We looked at power. We looked at different form factors. We also looked at if you're going to troubleshoot your system, how do you do isolation of your PC problems and the rest, and be able to also be good at research because typically there's nothing new. Most problems you're going to witness something like that have happened in the time past. Okay, today it's chapter 5, that is module 5, networking concept. So this is a very long module, um, 83 slides. So let's begin. Um, so all of this point, just intro, create slide content. Okay, start from here, right? Networking concept, or rather networking components and types. Now, network icons. So on your Cisco packet tracer, you have several icons. So this is what a switch icon looks like. This is what a router icon looks like. A wireless router, this is what it looks like. So it's signified by this, an access point, a modem. And this is what we'll call our intermediary devices, right? They're intermediary devices because they stay between your network, your end network, through your network media. So the network media icons you're going to see your packet tracer is this kind of stuff. It's your LAN media, anything that's going to connect between your switch and your PCs. So you have something like this. Then wide area network media, something of this nature. Then wireless. So you have this spiral kind of wire. The network cloud internet. Now hosts or endpoints. Uh, you have the desktop computer, you have the laptop computer, your server, your printer, your scanner, your IP phone, your smartphone, tablet, and of course camera. Um, so all of these icons, you should be familiar with them so that once you drag in and drop in on your packet tracer, it's going to be very easy for you. Network topologies and description. So there are different types of topology. When we say topology, we mean layout. How are you going to lay out your network? What are different ways you can lay out your network? So you have PAN, that's personal area network, commonly used for Bluetooth devices. Bluetooth is not so common these days, but let's say 5, 10, 15 years ago, wireless was not so much in vogue. So you have Bluetooth, so people could connect two phones together or between a laptop and what was it called? A phone. So you have limitations when it comes to small networks. Transferring large files is going to take longer. The speed is not that fast. That's one disadvantage you have within the personal area network. And that's not to say that you cannot have a peer-to-peer network. You can also have a peer-to-peer network between two laptops or between two PCs. It's still considered as a personal area network. You have a little bit higher speed when you do peer-to-peer via wireless. Now, LAN. A wired network consists of a switch and network devices. Like previously I said, if you have this switch, you have 10, 15, 20 of these guys connected to this guy through a LAN media Ethernet cable. You have a LAN area network. Then VLAN, so virtual LAN. So you could have a switch, but for instance, you have a 48 port switch or a 24 port switch. Let's take an example of a 48 port switch. If you have a 48 port switch, the thing is that you're going to put all of, for instance, this switch here. You have 48 of these items. You're going to put each and every one of them into this switch. But the downside is that you might not, uh, they might not be in the same department. right? They might not be in the same sector. They might not be doing the same kind of tasks within the workplace. So VLAN is a way for you to virtually within the switch divide it or sort it out or extend it into different parts. So that 48 switch port switch, you could divide it into, let's say, eight into, I think that you have about six places or so. So that will give you a virtual kind of switch. So each of those 8 ports will now operate like what was it called? Will now operate like an singular individual switch. So that's what you call VLAN. Extends beyond the traditional LAN and group users based on administrative defined boundaries such as department or floor. So for instance, this way you have a VLAN 2, VLAN 3, VLAN 4. So within this switch, this system is on a VLAN, this system on the VLAN, this system is on a VLAN. Same on this switch, same thing happens. So that all of these three switches within IT department can communicate and see themselves as within one switch. And of course, wireless LAN connects multiple wireless devices and uses an access point. You have this. So this is a personal area network. This is a switched network, a LAN. This is a VLAN demonstration, and this is a wireless LAN. Okay, network topologies and description continued. So you have wireless mesh network, something of this nature. You have metropolitan, something of this nature. You have wide area network, something of this nature. Two networks meshed together over the internet. Then virtual private network. So this is it here. So you have headquarters, you have an office, you have staff around the country or somewhere else connecting remotely. So what VPN does is that it creates a secure tunnel, right, over the internet between two endpoints. So this is an endpoint, this is an endpoint. This guy is in Amsterdam, this guy is in New York, this guy is in Nigeria, this guy is in Spain. But this is the headquarters. So how do we securely connect through this guy? Do we just get to the internet and put this guy public facing on the internet? No, that should not be a secure way to do that. So VPN helps you to have an additional layer of security. So it uses TLS. So you have security on this tunnel and the different types of VPN. We're going to look at that later on. The brief history when it comes to connection technology. So you have dial-up. This used to be very old. So you're going to have a modem, a telephone, hello, right? Or walkie-talkie. So it's going to have a phone port which uses an RJ11 jack. So you connect that, and that can serve as your model. Same thing, you have integrated device digital network, then of course you have broadband. So this is a little bit more current. So you have satellite receiver, this is a modem, so you connect this into this, and you could now connect to a switch, or you can now connect to other devices, and you can now provide internet facility or other resources. You should know that one of the reasons why you have a network, uh, it's not really just internet, right? A network is to help you share resources. Share resources. So resources can be anything. Resources can be files. Resources can be networked devices like hard disks, like CD-ROM, like what was it called? Like any gadgets. It can be a camera. It can be something that you want people to have access to. So not necessarily will a network provide just only internet. You could have a network and the sole aim is not for you to be able to provide internet. The sole aim is for you to be able to share files you have in a hard disk. So that hard disk is networked into the network, and everybody can have access to that hard disk and save files. Or you could have a CD-ROM somewhere, because most of the systems maybe they don't have CD-ROM, or they are what we call your thin clients, like we talked about when we did module 4. So those thin clients are just individual systems. They don't have all of the resources. in the individual mini kind of PCs. So if you have a CD-ROM somewhere in one system and that system is on a network, then you could share that CD-ROM or that optical drive on the entire network, so everybody can pick from the CD, the file on that CD drive and install on all of the systems. So you have sharing of resources. So you actually say a network is 2, 3 more systems or PCs or endpoint devices sharing resources. So the resource can be actually anything. Okay, let's move to the next one. So we have DSL, that's digital subscriber line. Then you have cable. Then you have Wi-Fi. Now, this is a little bit older, followed by this, followed by this. So this is more recent, fiber optics. So you have the description here. Now you have line of sight wireless. So I tend to call this point to point, where you have a radio here connected to a transmission mast. So you must have clear line of sight, right? Clear path required. If there's any obstacle, it's going to affect your transmission. So most network providers have this. So instead of using a regular modem, a regular Wi-Fi device, no. What you do is that you get a radio, a common type of radio. In the source of in the course of this course, we will see some of these things in detail. So you now have a radio here or maybe somewhere here, have a clean line of sight, most ubiquity, Cisco, different types of radio by different manufacturers. You could use them, connect to this point. Then this radios mostly and always, they're always wireless devices. So you could now uh, connect it into a router through a PoE device, a power over internet. So you have a cable running into this point. Then from that PoE device gets into the router. Then from the router, you can now send to other switches, and the home can now have internet access. So this is always most of the times used to provide fast internet, unlimited internet to homes, so that you're not restricted with maybe a modem or that kind of thing that might have speed limits and the rest. So for larger scale, for enterprise internet facility, this is one way you could provide internet using radio signal. Satellite. For bigger uh, internet services, you could have a provider, you have a dish here, then it is connected to a modem, then from the modem to your switch, to your router, you cannot be shared. Unlike here, where you have a radio, here use a dish, right? And an ISP is going to be transmitting to every other person. So you have the satellite in the cloud. Okay, cellular, right? If I'm going to connect through my cellular, normally most cellular phones have a radio device operating in different speed, different megahertz, different bands. They cannot connect to cell towers, and from there, you cannot have access to the internet. Okay, mobile hotspot and tethering. You should be conversant with this, right? We're talking about networking devices, how to set up a network, understand the concept, the components of you having a network. So why do you need to do hotspot and tethering? So there are different ways to do hotspot. You could do through Bluetooth, you could do through Wi-Fi, you can also do through a cable. So you call this USB tethering. If you use through Bluetooth, Bluetooth tethering. If you use Wi-Fi, you call it Wi-Fi or hotspot, personal hotspot. So most phones, you just need to go to the settings, look for the hotspot, you activate it. It normally have a key, right? So you could set the password. So this is the password, ITE user 123. So you could set that up, and every other person can share from this um, from this phone's internet. So the thing is that this phone needs to have an internet facility. So most Android phones, iPhones, and different types of operating systems of phone, they have this facility that will enable you to be able to share the internet facility you have on this phone through to other devices that can connect either through Bluetooth, through Wi-Fi, or through USB tethering. Protocol standards and services. So there's a video in the LMS. Please look at it. TCP, UDP sequence number, uh, transmission control protocol, user datagram protocol. So these are two types of connection. You need to very well be conversant with them, because even as you go ahead and do cybersecurity later on, you see that this informs protocols you need to be careful about depending on what technology, what implementation you're actually working on. So this is a stateful transaction connection. That's where you talk about the three-way handshake. This user datagram protocol, where it's not stateful, so it's stateless, right? It does not have, you have two guys, Mr. A, Mr. B, trying to communicate. For TCP, they both have to do hello, say, I want to speak with you, say hi, yes, I'm available, then before the communication starts. So they have to have a connection. So this one, that's why this one is called the connection-based connection. This one is called the connection-less based kind of connection. So they don't need to initiate a handshake first before the communication starts. Whereas for this, they need to initiate a handshake. So these have several uses and applications, like in web pages. If you need to browse, if you need to do some kind of stuff, this is applied. Whereas this for voice over IP, for video conferencing, most of those technologies they use UDP. Okay, this is it. Okay, yes, I even have it explained in the next slide. So this is your TCP model. Unlike the OSI model, you need to be able to understand the OSI model and also compare it with the TCP IP model. So the TCP IP model is a compressed version of the OSI model. So in the OSI model, I normally use this as kind of lead for my students. Please do not eat sweet potatoes alone. I actually love sweet potatoes. So if you eating your sweet potatoes alone, I'm not gonna be happy. So I say, please do not eat sweet potatoes always. So for the OSI model, you have please, that's physical layer, do data link layer, not network layer, take transport layer, sweet potatoes, sessions, sweet s session layer, potatoes, presentation layer, alone application layer. So you see, but the TCP IP model is compressed. So you just have network, two layers are merged, internet, then transport, then application. For every two guys, every two system to be able to network, to communicate, it goes through Mr. A up to Mr. B. So at both systems, you're going to have this protocol. All you just need to understand is that for you to have communication, it goes through these stages. If I have a system here having the same thing, the data comes in, it goes through my wireless device, my LAN, my switches, it goes through my, it has information about the IP, the source IP and the destination IP. It goes through this, then within your browser, within your phone, within your application, you can now see it. Same thing if you are sending information out to another system, you might be using your email Outlook or your Gmail. You might be browsing on the website using what's it called? Chrome or Firefox or Edge or Safari or whatever. Or you might be using file transfer protocol, trivial file transfer protocol. So it's a minified version of FTP file transfer protocol. This is for transfer of small files. This could do very large files. Now, or you might be using FileZilla. FileZilla is a software used by web developers to transfer files from their system up to their hosting server. Or you might be browsing on the internet, visiting a website. So at this point, you are using any of your software, any of your application. If you're sending an email, it's going to get done, use TCP, matches the IP address, source IP address, goes through your wireless device and hits over to the internet to the next person. So this just tells you how communication happens underlying within your system. Now, TCP, UDP, the two types of connections we have. So this just explains to you the two type of connections. So this examples application. So what are the characteristics? This is very reliable. Why is it reliable? There must be a handshake. There must be a connection before the transmission starts. Acknowledge the data, resends logs data, delivers data in sequence order. Right? For instance, if you're using FileZilla, file transfer protocol to transfer files to a server, most of the times if it fails, you have it there logged, it could resend it. That is this resends of logs data. But in UDP, it's fast. That's what makes it different from this. But this is reliable. So actually, this is not a matter of advantage or disadvantage. You will actually have them applied in different types of application. Okay, TCP. So this just explains all the things I'm trying to talk about. These are descriptions you have in the previous slide. Then of course, this is UDP. Now, there's a video, there's a slide in your LMS. You want to go through it and understand better on before you could have transmission, before you could have communication. You got to have data from where it is coming from the source port. You have thousands of ports in your PC. You could check up Wikipedia to have a list, and there are different uses. Some ports are reserved for some particular appliance, whereas some ports are for some particular purposes. Then destination ports. In our labs and our hands-on, we're going to be exploring some tools that can help us fully understand some of this concept, because it's very practical. If you use a tool like TCP view, TCP view is a very small script. It's less than 1 MB. If you install it, just open your browser, start browsing. You see that it's going to tell you all of the communications you're making, the source IP address, the destination IP address, the source port number, the destination port number. If you're browsing a website like southtechventures.com, isosec.com, you're browsing from your PC. Your PC have a port number that is going to transmit that particular web address. But that web address is on a particular server on a PC somewhere, and that PC is also going to have a source address, a source port number, and a destination port number. So it just tells you how things move from one point to the other. So please watch the video in your LMS, take your notes, and if you have questions, please do ask. Now you have different types of ports, right? And the ports work with different types of application. Anytime you hear port 53, understand it's used by DNS. It uses TCP UDP. So what do you call domain name service? If you go to whois.com, for instance, most of us have started a cybersecurity training. So if you need to understand this, go to whois.com, put in a website name. You're going to see the server, the domain name server. That's to say, if you're going to host any website or any email or any domain or whatever, it's going to be hosted somewhere in a server, in a hosting server. And what do you call a hosting server? Typical, that's why it's called a server. A system somewhere that's available 24/7 that helps provide information or serve information to the outside world, to the outside public. So it must have an address. So the address can be, for instance, our servers, it can be ns1.celtechhosting.com. So that is the name of a server. So that uses port 53. So anytime you are to query that server, it's going to be going through port 53. Same thing applies to HTTP. So if you are browsing anything over the internet, the unsecured version is HTTP, whereas the secured version is HTTPS. You should be able to understand all of these items, at least understand up to 15 to 20 of them, and understand the application. For instance, simple mail transfer protocol is port 25. POP and IMAP are used for email also. If you've configured Outlook, or if you've configured a corporate email or a website email on your phone, you're going to see it ask you to choose any of these protocols. Then you have LDAP, you have TCP, you have rather SSH, you have Telnet, and you have RDP, remote desktop protocol. So if you do remote computing from one Windows PC to the next, that's the protocol that's going to be used to transmit data. Okay, now, okay, this is a continuation. So you just have them. Please go through them, memorize them, take your notes. And if you have questions, please ask. Then you have different standards. So it starts from A, B, G, and AC. Maybe the next 3 or 4 years, we might have another one. So this just tells us the maximum speed that it can allow. Back in the days, most of these devices have limit on how much speed they can take and how much range they can have, right? And at the frequency in which they operate. You see this backwards compatible. It tells you that this guy can operate at this guy, right? So you see, it's compatible with this guy. Whereas this guy, N, very awesome. It's compatible with A, B, G. So it's compatible with A, B, and G. So this guy, AC, compatible with only A and N. Only this guy and this guy. Okay, Bluetooth, near field communication, NFC, and RFID. So these are different ways that operates like a mini network that can help you make some identifications, especially for NFC. So this is NFC, or rather this is RFID, this is NFC, and this is Bluetooth. So these are their details. Okay, yeah, ZigBee and Z-Wave. So you have this is their details also, these are their details. Cellular generations, 1G, 2G, 3G, 4G, LTE, 5G. 5G is a little bit used for high speed internet. Adoption is still growing within countries around the world. LTE replaced 4G, so you can have up to this speed. Most routers have up to this. A good number of phones now are 4G compliant. Then you have 3G, you have 2G, then you have 2G. I remember when we used to have 2G, even when you have 9.6 kilobytes per second, it was very fast. The reason why it was fast is that the files you're trying to transmit are not too large. But these days, you have high pixeled data, so you need something fast in this range, right? You need something fast in this range, and to be able to transmit fast, you need fast internet, right? So what it just tells you that I can transmit 1 gig in 1 second. So if I have a 200 gig file to transmit just in 200 minutes, which is averagely 60 minutes, 120, 60 minutes, that should be 180 minutes and 20 minutes. That's 3 hours, 120, 3 hours, 20 minutes. I should have downloaded 200 gig. If you use this, you spend a longer time. If you use this, you're going to be spending days. I remember when we're still in 2G, where you're doing a Bluetooth kind of tethering, and you have you're trying to download a file of 1 gig, and you're told uh, 49 days counting. So you ask yourself, I think I have to make do with whatever I have. I will not be able to download this. But these days, you could download 1 gig file, 10 gig file very, very fast because you have very, very fast internet. So this just tells you the generations, right? From this to this. And if you do some research, you're able to know the years in which some of these technologies started becoming very highly used. Okay, there's a videos explanation slide to explain these protocols: DHCP, Dynamic Host Configuration Protocol, DNS Domain Name Server, and Hypertext Transfer Protocol. So what this guy, what it does for you, it works together with ARP, or Address Resolution Protocol, within your network device. What it does for you is that, for instance, if you're on the network, you have a wireless router. What happens is that you will need to have access to the router, right? So that you can have maybe access to internet or have access to files or have access to a printer or have access to whatever. You will need to have an IP address. True or false? I guess your answer is true. If you need to have an IP address, the question is who is responsible for issuing you an IP address? When we talk about DHCP, we are referring to dynamic host configuration protocol. Because in your PC, you could have two types of configuration. You could have a static IP, you could have a dynamic IP. So you want to use static IP for devices that you know are really not going to change over time. Things like your printer, some servers, some laptops and some things. You want to give them static IP so that they don't change, or some critical infrastructure. You don't want them to be changing IP address from time to time. But all your regular end devices, they can use the DHCP. So within the router, this protocol is in charge through and also using the ARP, the address resolution protocol, to assign IP address to each of those endpoints. And the thing is that two PCs cannot have same IP address. If there's an IP, if there's a same IP address, you have an error, there's a parity, there's a error correction, there's a check. And a way to do that is just to reset your network or restart not really restarting the laptop, that would be a long haul. Just reset your network, or not, you might, if that does not work, on the long run, after so much, you could reset or restart the router. It's going to reassign each IP address to each of the systems. But the very minimal one is to go off the network. By the time you're returning, it will be able to send DHCP discovery messages to the router, and it's going to assign it an IP address. So that's the guy that is in charge of that dynamic host configuration protocol. Whereas DNS, I've already explained that. That's within your hosting service, your domain name server. Then HTTP for most websites. So you have different types of client server roles. So you have file server, what it does, gives files, documents to people. Then you have web server and its clients, same thing. Then also you have email client server. Okay, I think I've explained this just a while ago. So DHCP server provides IP addressing information. So this is the guy here. So here we're using a server for that purpose, but this is another server for that purpose. But most routers are going to be able to do this function, right? Even your phone is going to do that function, right? Your phone will be able to assign, when you do hotspot tethering, it's able to assign IP address to all of the persons connected to it. So this is what I explained earlier on. The CISCO, if you go to your command line prompt, your CMD, and you you say ping www.cisco.com, you're going to get an IP address. So, but that's what it's matching this file within the DNS server. Okay, a print server. So what it does is that controls multiple printers, allows centralized print jobs administration, and provide feedback to network lines. File server, so this is what it does. So it uses all of these protocols, your file transfer protocol, your this, and your this. So all it does is that provide files to clients that are trying to access the file. Same thing with the web server, also same thing with the mail server. They all function for those different purposes. And these are the different protocols that they work with. So if you hear a protocol, you should be able to tell what are the list of protocols that it uses to be able to function. Proxy server, right? So it just acts on behalf of the client, hiding the real internet host. Uh, Most proxy servers are going to use IP addresses too. So you want to access this web page. For instance, if your country, let's say your country is Afghanistan, and Afghanistan, they said, okay, you cannot access this US website, so your IP address is banned. So you could just get a proxy server. Different applications of this is when you also use an anonymizer, like Tor, like Hide My Ass, like all of those different applications. So they act as a proxy so that from you here, you could now access the internet or the web page. Authentication server. So it does authentication, authorization, accounting. During the cybersecurity class, we learned some of these things, and they are very, very self-explanatory. Syslog server, system log, very Cisco proprietary, and it just helps for messages. It keeps log of all of those back and forth network messages. If you have error messages, that's one of the places you want to go check up. Basic network devices. So what are those devices that we have in our network? There's an LMS explanation of this. There's an explanation in the LMS, so please watch through it. Take your notes. If you have questions, please do ask on the WhatsApp group and I will be there to answer. So NIC, network interface card, that's this guy here. So this guy is an NIC wireless for that matter, but it works through the USB port. That means it's going to have a driver, and some of them can be also plug and play. You also have them come in very small size, even just as small as this. You can plug them; they act as wireless. For instance, the PC does not have a wireless device, or you're trying to do some loop back, some connection, and you need two wireless within your PC. You could purchase a USB NIC, or you could have something like this. This PCI, right, slot, expansion slot, so you have this behind your PC. Or you also have this as PCMIA, right? You have it in some laptops, so you could also have this inserted. Now, repeaters, bridge hops. So you should be able to understand the clear-cut difference between a switch, a router, a repeater, a hop, and a bridge. They are all network devices. What a repeater does is that it extends, serves like an access point. So it's like add to the signal. For instance, you have a hall, and from point A to point B is 10 meters, from point B to point C is 10 meters, and that particular router cannot go up to 10 meters. So from point A to point B is 5 meters, point B to point C is 5 meters, all the complete range should be 10 meters. But that router can only go up to point B, which is just 5 meters. So what do? You need a repeater. So it's going to replicate the network to the signal strength of where you're replicating from. If you have here at this point 3 bars, it's not when you have a repeater, the repeater is going to now make it like you have 5 bars. No, these 3 bars you have here is going to replicate or repeat these 3 bars for the next 5 meters, assuming it can go for 5 meters. A hop receives data on one port and sends to all other ports. So it's not too efficient. So hop bridges are not so much in use these days. Uh, we use more very intelligent layer 2 switch and layer 3 switch, and of course routers. The switch. So what the switch does, it does forwarding. That's the summary of what a switch does. So you have different switches, and they operate at layer 2. You should also understand that switch is a layer 2 device. Don't forget, when I say layer 2, I'm talking about the OSI model. Then you also have wireless access points. So they provide access to wireless network for a limited range. So you have a switch and you have an access point. Or for instance, let's assume you have a switch here, you have an internet router here. Then all of these guys are connected through cables, Ethernet cables to this guy. Then this access point connected to this switch, maybe it's on the third floor, is going to help extend. So an access point also can serve as a repeater. Router. So routers are layer 3 device. So don't forget, please do not take sweet potatoes alone. Please do not. Network N. So it operates at the network layer. The user IP address, whereas the switch uses MAC address. So you should understand that. I should understand that a MAC address is a layer 2 device, it's 48 bit. The switch is, yes, the switch is a layer 2 device, It uses MAC address 48 bits. The router is a layer 2 device, uses IP address, right, which can be IP version 4 or IP version 6. IP version 4 is 32 bit, IP version 6 is, I think, 128 bit, right? So you should be able to do the differentiation between these items. Okay, so good enough. You have a video explanation on the elements that explains the firewall, integrated router, access control list, intrusion detection systems, and intrusion prevention systems. So this is how they work. So the reason why you have these guys is to protect your network. So this gives you an explanation. When you get to the Cisco Cyber Ops training, this is a module on its own. This is a chapter on its own. So we're going to be looking at them extensively. Firewalls protect. So this is what I just talked about. Intrusion detection system, the monitor traffic and its passive system, intrusion prevention. So this does not just detect, it detects and prevents. It takes action actually. Okay, so UTM's Universal Threat Monitor Management is only one security appliance. So what they do is I put them on your network. They will help you do some email filtering. They can also help you do VPN services and the rest. Protect you against denial of service and distributed denial of service. So you should be able to understand the difference between zero-day attacks, DOS attacks, and distributed denial of service. And we're going to see this more in cyber ops, right? Okay, but let me just add a little flesh to it. Now, when you say you have a zero-day attack, 0 day, zero, before, for instance, let's say you have a software. The software is XYZ, and we have public using that particular software. Now, it might have some vulnerabilities. In our cybersecurity class, we talked about I gave you an equation of an attack. Before you can have a cybersecurity attack, you need to have a motive for the attacker, a vulnerability, then a method. So these three items gives you an attack. So you cannot have an attack if you don't have a motive. There must be a reason. There must be a hack value. There must be a reason why an attacker wants to attack. If there's a reason, what it looks out for is for vulnerabilities, is for loopholes, is for misconfiguration, is for flaws. That's what cybersecurity experts, most of the job you do is checking out for vulnerabilities, patching them, doing documentation, scaling up things, and making things more secured. So for the attacker, he's going to be looking at how vulnerable are you? What are the vulnerabilities we have within our network, within our system, within our IT infrastructure? So that's what the attacker is going to be looking at. If you can get a vulnerability, the next thing he's asking himself is, what method can I use to attack this vulnerability? What exploit is going to work for that? So if you have a software like I gave as an instance, it's shipped to the public is using it, and you have an attack, a vulnerability, before the owners of the application is aware of it, you call that a zero-day attack. But the thing is that if you have good appliances, they can use heuristics, they can use different patterns to be able to detect that this is an anomaly and are able to block this kind of transmission, this kind of communication, this kind of transaction. So that's why these devices, they are good. So even if that patch has not been released by the vendor, you could still have protection. Whereas for a denial of service, you say denial of service when you don't have access to your IT infrastructure. It can be a website, it can be a cloud server, it can be an email server, it can be a printer, it can just even be a hard disk. It can just be a public facing website or an intranet. Once you don't have access to that, that's denial of service. So, but there are different ways the denial of service can be deployed. So, but before you say, I have a denial of service, you want to make sure that you don't have interaction with your vendor, or you don't have a misconfiguration, you don't have an issue internally. Whereas a distributed denial of service is when you have the denial of service, but that attack is conducted from different persons. For instance, Let me just, I'm just trying to be as very plain as possible. You have 50 systems, 100 systems in layers attacking one PC. That's a DDoS. But if you have one PC, one person attacking a particular IT infrastructure, a particular IT target, so you call that denial of service. Anytime you hear the word endpoint, you talk about those guys at the tail, those guys that connect to my intermediary device, my switch router, and the rest. Okay, so legacy. Yes, you have some old devices that might not be in support, but they are still in operation. Okay, you have patch panels. So it's a traditionalized place where network panel cables attached to the back. Patch cables are used to make a connection to another patch panel, which connects to different wiring closet or to device such as a switch mounted nearby. Very self-explanatory. So I was talking about a PoE, power over internet. So this guy, what it does is that if you have a radio, for instance, you have a radio that's going to be, let's say, 100 meters. Let's say you are in, you have a 10-story building and you are in fifth floor, but you have clear line of sight of your radio to another cell tower on the 10th floor. I hope I'm not confusing you. Simply put, you have a radio that is far away from where you have your switches and router within the building. And you know, for every router, every radio, they need two things. And for most devices, data and power. What did I say? Data and power. Just like your hard disk will need data cable and power cable, right? Even this your switch you are seeing here, you need to power it up, then you need to connect a cable to transmit data. Same thing for a router you have in your home. You need to do what? You need to power it on, then you need to connect your cable or use wireless to be able to collect data. For your phone, for instance, it needs to be on, it needs to be powered on, then you need to use through wireless or through cable to transmit your data. Same thing for that radio you have. You need to send power cable, Ethernet cable. But the point is that for you to be sending power, of course, you know, uh, standard carton of a Cat5 or Cat6 cable is about 300 meters. So you can go that length, but for you to start making provision for power, that will be more expense and that might have some other issues. So what happens is that you could just put an internet cable from here to your radio, then this cable from here to your switch, and you're fine, or your router. So what happens is that this cable is going to transmit power and transmit Ethernet also. That's why it is called power over Ethernet. So this cable is not just transmitting Ethernet, it's also transmitting what? Power. Actually, your four twisted pair of cables you have in your other Cat 5, Cat 6, Cat 7, Cat 8. Yes, you have up to Cat 8, and I think even Cat 9 cables. The four pairs of cable there, you're not using everything actually. You're using just few of them, and the rest can be used for power. Cloud-based. You want to control your network through cloud-based device, so you could do that. Most routers, switches, and endpoint remote monitoring tools can give you that access. Network cables. So you have different types of cables. You want to learn how to crimp your cables. So you have a video explanation of that. Yes, this is it. This is your cutter. You can use this to also cut depending on the size. This is also a cutter. This is your crimping tool. This is your tester. This is your multimeter. You use this to test for continuity. Your loopback adapter, you can also use to test for continuity and to check your strength. Tone generator, funny enough, uh, in some houses you're going to have wires. You're going to have wires around the building, and you might have wire A, and you have wire B somewhere, or wire one end of wire A and one end of wire A in two parts of the building. So the point is that how will you know that this is actually wire A? For instance, if there's no labeling, so you put one end of the tone generator in one cable and you go and probe the other part. So once you hear the sound, you now know that yes, it's actually cable one. So that's how it works. So we looked at this earlier on: twisted pair, coaxial cable, and fiber optics. This is for high speed internet. Light, uses light wave. Thousands of kilometers per second. Okay, so very self-explanatory. Self-explanatory. So that's the twisted pair: 4, 1, 2, 3, 4. So it's twisted, right? It's also color coded. It's something you need to learn how to crimp these cables. I can remember when I was doing a networking tax particular time for about 50 pieces. Somebody came in and said he could help. I said, right on. If you don't do this thing properly, it's not going to work. So after some time, I saw he was doing some mess. So I told him to stop, because if you don't get it properly, you have to cut this cable and redo it. So it's something you need to learn. It takes you 1 to 3 days. With constant practice, you'll be able to, and you have different configurations, right? Different standards. So you could use it, align the cables properly, you cut it, you crimp it, put in your RJ45, and you're done. Yes, for the different types of cables, it tells you the speed. So Cat5, then Cat6. Yes, these are the standards, these are the scheme. So this is T5688A, this is B. So these are color labels, these are color labels. Demonstration. So please watch this video. It's just like myself doing it. So it's going to be very, very hands-on and very practical. So you could please do that and follow up. Make your notes, have questions, please ask. So in that lab, you want to build your cables and you also want to test them. Okay, same thing with fiber optics cable. Types of fiber media. So you have this SMF, you have MMF. You have your connectors, ST connectors, SC connectors, duplex multi-mode connectors, and your LC connectors. So that's all. It's a very long module. It's 52 minutes long, invariably 1 hour. So we learned about the components of your computer network, your protocol standards and services, the purpose of your devices on the network, and the characteristics of the different cables you have on the network. Thank you very much. That will be all. See you in the next module.